There are three distinct types of plate boundaries, and these are differentiated by the type of movement they exhibit. First, let us discuss about divergent boundary. Divergent boundary is where two plates, let's say these, two plates move away from each other, creating a zone of tension. And in here, from here, the magma from the mantle oozes up to fill this gap, and as the plates continue to move away from each other, the formation of oceanic ridge or rift valley appears. The second type of plate boundary is called convergent plate boundary or convergent boundary. This is where two plates move towards each other. Under convergent boundary are three subtypes. It could either be continental oceanic, oceanic, or continental. Since we know that there are two types of crust, the continental crust, which is thicker but less dense, and the oceanic crust, which is thinner but denser. First, let us consider continental oceanic. Let's say this plate here is a continental plate and this is an oceanic plate. When these two converge, since oceanic plate is denser compared to the continental plate, what happens is it subducts, creating a zone, subduction zone there. And what happens furthermore is that the subducted plate, this part here, melts and it becomes magma plus water. It becomes less dense and oozes up in here on the edge part of the continental plate. So what happens is it forms a volcanic arc around here in the edge of the continental plate, and in the edge of the oceanic plate a trench was created in this part. And of course, as the two plates converge, pressure is released and an earthquake is present. Another one is the oceanic. Let's say these two are both oceanic crust. Yes, they are both oceanic crust, but eventually one will be denser than the other. So let's say that this is the denser oceanic crust. So what happens when they converge or when they move towards each other? The denser plate subducts, and just like with the oceanic continental, the subducted plate melts and turns into magma. It oozes up, reaches the surface, and it forms a volcanic island arc, since both of the plates are oceanic crust. And in here, a trench is present, a trench is created, and also earthquake happens or appears. The last subtype of the convergent boundary is the continental. So let's say that these are both continental plates or continental crust. What happens when they converge? Since continental plates have low density, what happens when they converge is they fail to subduct and pressure is released, pushing the crust upwards, thus forming mountain ranges. The best example for this is the Himalayas. The third type of plate boundary is called transformed fault boundary, wherein the plates slide past each other. And as the plates grind past each other or slide past each other, pressure is released, causing earthquake. You already know that there are three types of plate boundaries: the divergent, convergent, and transform fault boundary. We've also discussed that plates could either move away from each other, move towards each other, or slide past each other. But the question is, what drives the plate movement? Because we already know that the plates do move. What drives these movements, or what is the driving force behind these movements? The answer lies in the layer called asthenosphere. This is the layer underneath the Earth's lithosphere. And now we are going to do a representation of what is going on, or what happens in the Earth's asthenosphere. So in here we have liquid food coloring and a bowl of water, which I already put some of our food coloring, and a glass of hot water. This here is a representation of what happens in the Earth's asthenosphere. So the outer core, or glass of hot water, releases energy in the form of heat. And materials in the asthenosphere, when heated up, becomes less dense and flows upward. And when it cools down, it goes back down. And this is a representation of what happens in the Earth's asthenosphere. Materials, when heated up, becomes less dense and it goes upward, and when it cools down, it goes back down. And this cycle continues. This is called the convection current. And since plates act as a raft on top of the flowing asthenosphere, plates move with the current.